Hello, here's a little introduction video to Unit 6. These are the things that the unit assumes that you already know as you start learning about systems of linear inequalities. Okay, when you classify numbers, we have, first of all, natural numbers. This is the smallest circle. This is an N that stands for natural numbers. Natural numbers are the numbers that you learn as a small child. They start with 1, 2, 3, and they go up. Okay? So natural numbers include everything from 1 and above. Then you learn about the idea of 0, and whole numbers then include 0 as well as all the natural numbers. They're represented by a capital W. Next, in life, and in the number of classification comes integers. So integers include all natural numbers and all whole numbers, as well as all the whole opposites, so the negatives, etc., all the way up into infinity in the negative direction. Lastly, the real numbers. So real numbers include everything in between all these numbers, meaning the decimals and the fractions. So real numbers include all the natural numbers, they include all the whole numbers, it includes all the integers, as well as all decimals, or parts of the numbers, everything in between the previous numbers. We say that real numbers are continuous because they include everything, every tiny little fraction in between all the integers and whole numbers and natural numbers. We find that real numbers are also divided into two categories. We have the rational real numbers. They can be written as a ratio. So something like 2 over 3, that's a ratio. Negative 46 out of 47, small decimals. Sorry for that rumbling. And the ones that can't be written as a ratio are not rational numbers. These are irrational. They're the crazy ones. Numbers like pi, it's a decimal that goes on forever, and it can't be written as a rational number. Another one would be root 2. It's a root 2. We can't write it as any kind of fraction. It's a decimal that continues on forever. Okay? Next thing to remember is inequality signs. We've got greater than, we've got lesser than, we've got greater than or equal to, and lesser than or equal to. I'd like you to write these inequalities in the list on the right here. Pause it, and when you press play again, the answers will be revealed. You can pause this again and check your answers over. Okay, then we're talking about solving inequations and inequalities. We solve these the same as we would any equation. The first one here, we want to get x by itself. And in order to do that, we need to subtract 6 from both sides. Okay. And the next one, similarly, you see it's an inequality, not an equation, but we use the same steps. We need to subtract 4 from both sides in order to get that 0, to get m by itself. The next one, 3 is being multiplied by h. So in order to get rid of that 3 in front of the h, we need to divide, the opposite of multiply. Here, same thing. We divide both sides by 8 to get p on its side by itself. And the last one, we see w is being divided by 6. The opposite of divide by 6 is multiply by 6 on both sides. 6 over 6. Okay, so we see solving equations or inequalities, same steps as solving equations. Now, here's the next step in the difficult level. The intention here is to get the variable alone on one side. And so each of these will have a few steps to do that. You can try this in your book. When you press play again, after pausing it, the answers will be revealed. Okay, so in the first one, in order to bring the y's together, let's add y to both sides. Negative y plus y, that gives us 0, will cancel out. And on this left side, we'll have 10y plus 45 is equal to 135. That's frustrating. Then we're still trying to get y by itself, so let's take this 45 over to the right. We subtract it so that there's 0 45s here. And then we've got 90. And we're still trying to isolate y, so we need to get rid of that 10. We divide both sides by 10, and y equals 9. This second one is similar. We distribute these numbers through the brackets first, and then group our like terms. And this last one here, we see division by 2 and division by 6. The opposite of divide by 2 is multiply by 2. The opposite of divide by 6 is multiply by 6. So we see if we multiply both sides by 12, that will get rid of the denominators. On this side, 12 divided by 2 will be 6. So in fact, we're going to multiply everything through by 6. And 12 divided by 6 is 2, so in fact we're going to multiply everything through by 2. A lot of times teachers have taught this to be called cross multiply, where you multiply that side by 6 and this side by 2. It means the same thing, just my reasoning initially was why you're doing it. I like to show the reason why instead of just memorizing cross multiply. So then once you do it, that should be your answer, assuming I didn't make any little errors. Okay, another thing you need to remember when you're dividing and multiplying by a negative. This is very important. When you're dividing or multiply by a negative, you flip the inequality. Okay, very important. So for example, here in order to isolate d, I need to divide by a negative 3. When I divide by a negative 3, it's going to flip the sign. So now d is going to be less than negative 10. Similarly, in the second one, in order to get rid of that negative 2, or to get t by itself, we want to multiply both sides by negative 2, or cross multiply. And we say that t is, flip the sign, less than or equal to positive 10. Okay, very important. Go disregard this. That's for my in-class students. Okay, moving on. It's a lot of information, and we're going to get through it all in 15 minutes. We need to remember about the Cartesian coordinate plane, quadrant 1. That's where both the x and the y are positive. Quadrant 2, quadrant 3, quadrant 4. When we talk about quadrants, it's just standard form to use Roman numerals. So we denote them like that. Remember that all coordinates, everyone, ordered pairs, are always the x-coordinate, this is the x-axis, comma, the y-coordinate, and the up and down, the vertical, is the x-axis. Of course, the origin, when we talk about that, that's 0 on the x and 0 on the y. That's this spot here. Okay? Again, disregard the assignments. Moving on. Linear equations have two variables, usually an x and a y, but it doesn't have to be x and y. Both variables have an exponent of 1. We say linear equations are of the first degree. So when we talk about a degree, that's the highest exponent in an equation or an inequality. Linear equations form well, the key is here, they form a line when graphed. The tiltedness of a graphed line is called the slope. And hopefully this rings a bell from previous math classes. We use the letter m to mean slope. For example, a line that's this way, we say the m is positive. It has a positive slope. Lines are read from left to right, just like any word. If I would write my name here, of course, left to right, the same way as I draw a line. So this line is going up, it's positive. If a line is heading downward, left to right, we say the slope is negative. If a line is completely horizontal, flat, we say it has a slope of 0. That's easy to walk. And if something is straight up and down vertical, we say the slope does not exist. Okay, we'll disregard that. Let's move on. At any point you can pause it and or rewind and watch something. Okay, slope is m is also equal to the rise over the run. And this should be old information as well. So let's look at the orange line first. So in order to find the slope, I would find a place where this line intersects the crosshairs of the grid. So maybe right here and right here looks quite close. And then I would count how much this has gone up. This is the rise. Over how much it's gone over. This is the run. Okay, so let's call that line 1. Line 1 has a slope of a rise of 1, 2, 3, 4, 5, and a run of 2. I would like you to do that same thing with the green, black, and blue line, and then press play again to check your answers. That looks good, except for the very first one I did with you. This line is going downward, so we know it's a negative slope. So we would say 5 down and 2 right towards the positive. Okay, flip the page. So we know that slope is the rise over the run. And we can also calculate rise and run without counting on a graph. So the rise means the up and down, right? Up and down is the y-axis. So if we find the difference in the y-coordinates, which is y2 minus y1, and we divide that by horizontal, that's the x-axis, of course. If we find the difference in those points, we would be able to calculate the slope, the rise and the run, without counting on a graph. And that's what we're doing here. So for example, and first I'm going to pick which point is point 1 and which is point 2. So I can stick it into the formula. Slope equals y of point 2, 12, subtract the y of point 1, 4, over the rise, x of point 2, minus the x of point 1, which in this case would be 8 over 7, positive. Okay, so this line would be going up. And you can do these, press pause, and play to check your answer. And there's your answer. Of course, reduced is always easier. We have slope-intercept form, and we're going to use this slope-intercept form a lot in this unit 6. Slope-intercept form is y equals m, that's the slope, x plus b. The other form here would be called standard form. Standard form of any equation means that all the numbers and variables are on one side, usually the left, but it doesn't matter, and there's a 0 on the other side of the equation. So standard form in this case would be, we usually say ax plus by plus c equals 0. Excuse me, of course the x and the y are the variables, and a, b, and c are just the numbers, the coefficients in front of the variables, and the constant term with no variable. Okay? Alright, so from looking at this in slope-intercept form here, we can figure out the slope right from looking. So you can see this first example is in slope-intercept form. The slope in this case is a rise of 2 and a run of 3. Slope in this case, rise of negative 3, run of positive 7. Rise of 1, run of 10. Rise of 4, run of, if there's no denominator, we would say 1. Okay, I was hoping I could get this all in 15 minutes, but it looks like I'm going to have to make a short second video. Okay, we'll stop this one and continue on the next video. There's a max of 15 minutes, so I'll cut it off here.